Welcome to a lesson with Dr. Powell. Let's take a look at finding the curvature in the last example. In the last video that we had, where we computed the tangent, unit tangent, and the unit normal. Okay, so here I have part of the work that we had in that video. And at least we got to this point, then we could take a derivative with respect to t of the unit tangent vector. This is the unit tangent vector. And we end up getting this. So remember that the curvature is the same thing as the length of the vector dt ds, which is the same as the length of, so we could take dt divided by ds dt, and this gives us the exact same thing. And so ds dt is nothing but the absolute value of the velocity itself. So, I mean, you could think of it as a positive number here with respect to arc length as you go in one direction. Okay, so so the length of velocity here, we end up getting square root of 2 cosh t. So this right here is just square root of 2 times cosh of t. And then on the top, well, we have the derivative here. We just need to take the absolute value of this, which we did before. We'll kind of go over it again. And then we take the square root, and then we square this. This is secant to the fourth. This is secant squared tangent squared. So I'm going to kind of remembering what we did in the last video, since we're going to factor out a secant squared out of this squared and that squared. So we'll be left with secant squared coming from this guy. And on this one, this is secant squared times tangent squared. So the secant squared has come out. So we're just going to have plus tangent squared. And notice that this part is just 1. So just taking a derivative, we have, or the square root, I mean, taking the square root, we have 1 over root 2 times secant of t. And that will be the length of, and that quantity right there will be the length of this dt dt. So we end up getting, let's see, 1 over root 2 times secant of t, like just like that, secant of t. Okay, and this ends up looking like, simplifying this down, like basically this is like 1 over root 2 cosh t, and it's in the denominator. It's like it moves to this denominator to combine with it to be like 2 cosh squared t in the denominator, like this. Or you could even think of it as 1/2 secant squared of t. So what we just computed is we computed the curvature as a function of t. So the curvature will change over time. And we could think of the curvature of this as being that quantity. Thanks for watching.